A Bezier curve was the first computer-based approximation of the physical splines used in ship and car design. A car engineer at Citroën in France called Paul de Casteleu produced a number of algorithms in 1959 that could be used to model a simple computer version of the spline. Pierre Bezier, working at Renault, again in France, used Casteleu's curves to aid his car design work, and he evangelized the use in design. His work using these computer-based splines mean that we now generally refer to splines using his name, i.e. we call them Bezier splines. Though of course Casteleu's work is actually the basis of these systems. And indeed there were many other people working at the time who also evangelized and helped in the development of these curve-based systems. The simplest Bezier curve is made up of two control points. Between these control points, a line can be drawn, and these types of curves are referred to as being a linear Bezier curve, because they can only be used to describe a straight line through space. Of more practical use is the quadratic curve, and this uses a third control point, which is placed somewhere between the first two. This third point defines a directional vector for each end control point to try and pass the curve through. This produces a curve, though one where the level of control is actually not particularly fine, as in effect each end control point has to share the same directional vector. And that means that, as an example, the quadratic spline can't actually describe an S-curve because that would require a control vector for each end of the line to be pointing in opposite directions. So it has that limitation. However, limitations aside, quadratic splines can be used to create very complex curves simply by chaining a number of them together. So they're not completely useless. And they're actually used as the basis of TrueType fonts, which are the Adobe fonts that I described earlier. So quadratic curves are actually used quite frequently in 2D and 3D software to some degree or another. And the next level of Bezier curve, and the current implementation usually found in most 3D packages these days, is called the cubic spline. And this adds another control point between the two endpoints. And this now gives you control for one vector for each control point along the spline. These control points can be thought of as directional and strength control at each end of the spline. The control point defines a direction that the curve starts off in, and the force in that direction is based on how far away that control point is away from the endpoint of the spline. This means that the curve itself doesn't actually pass through the two control points, but instead it uses them to define its curve direction between the two endpoints. In 3ds Max, a spline is made up of two basic elements, and a number of these elements make up a spline. Let's have a look at these. And we'll actually have a look here at a linear spline, a quadratic spline, and a cubic spline. But I'll actually have to simulate a quadratic spline, as they don't really exist in 3ds Max. So let me just go here into 3ds Max, and I'm going to go down to here, Shapes. You can see we're in the Create panel, so we're going to go to Shapes. And shapes are either splines or NURBS curves. So we're going to be looking at splines here. Now, line allows me to actually draw a Bezier curve on the home grid here. So I'm just going to draw a few Bezier curves, and I'm going to use those to describe what we're actually working with here. So I'm going to create a control point here just by clicking, and I'm going to drag around and create a control point here. And right click, and we've defined that spline. Now I'm going to create another one here, pretty much similar, the same kind of thing. Right click to just cut it off there, and I'm going to create a third one here. Now I'm just going to go in and edit these just to illustrate some of the points. Just going to do some stuff here. Create Bezier, and let's just edit these a little bit. I'm just going to put these into a certain configuration just to illustrate my points. So let's put this here. And there we go. I'll just hide the grid for now, just so we can see these a little bit more clearly. So what I've just created are basically the three types of spline that I described. this is a linear spline. I clicked here and it's drawn a straight line between the 2 points. So this is a linear spline. This is a quadratic spline, and you can see that these are actually the control points here. And I have to simulate a quadratic spline, and to do that I'm actually putting the control points in exactly the same point in space. But I have to do that, as you can see, one at a time. But these are actually quite a good simulation of a quadratic spline. Now, there's no way that we can create an S shape like this, because in a quadratic spline, the control point, there's only one actual control point. So, and they're always, that control point is shared between the two, so they're always together. So you can create a curve like this, but you can't actually create this kind of S curve that you can see going on here. Now, this is a cubic spline. Let me just increase the interpolation here, just to make it a bit more curvy. And you can see the difference with a cubic spline is that you have 2 control points and they're independent of each other. So you can basically put them any kind of orientation that you want. And as a result of that, you can actually create this kind of S shape that you can see here. And as I've just said, that's not actually possible with a quadratic spline that you can see here. So let's have a look at the basic elements that actually make up these splines, and you'll understand what we're actually talking about here. Now, the first element is called a vertex, and it's also sometimes called a control point. And a vertex, as with a polygonal mesh, is simply a point in space. And that point can be anywhere in the 3D world, and all useful splines have to have at least 2 vertices in them. If you don't have 2 vertices, you can't actually define a segment. And a segment is the most basic kind of spline curve. So all splines have at least 2 vertices, and a lot of splines have many, many more. So that's it. We have, in this particular spline, we just have 2 vertices. Between the 2 vertices, we have a curve, and in 3ds Max, this is called a segment. So if I click on the segment sub-object type here, I can actually click on the segment itself. So a segment is a line which is drawn between the 2 vertices. And a segment always only passes through just 2 vertices. So in effect, you have a line with a vertex at each end of it. The segment can be one of 2 curve types in 3ds Max. It can either be linear, which means that it always forms a straight line between the 2 vertices, or it can be a curve. And in this case, it's a cubic curve. It's not a quadratic curve. Quadratic curves don't actually exist in 3ds Max. And as we saw earlier, a cubic curve means that it can actually have 2 separate control handles. So if we look here, you can see that if I just go back to vertex mode and select the 2 vertices, each vertex has its own control handle, and each of these handles is a vector, and it allows us, as you can see, to define a direction and a force in that direction that the curve tries to match. And it then interpolates between these 2 vertices and uses the strength and direction of these control points to define the curve that goes in between here. And this curve is called a segment. So you may be wondering, what is this last element here? And as you can see, it's called a spline. So if I click on this, this may not actually make any more difference at the moment, because our particular object that we have here only has 1 segment in it at the moment. But anyway, by definition, a spline is a continuous set of segments. This may sound odd, but a single editable spline in 3ds Max can in fact be made up of very many splines. So the way 3ds Max describes it is that a single segment, which is basically a single Bezier curve, a single Bezier spline, that is called a segment, as we've just talked about, and a group or any number of these curves combined together in one object is called a spline. So each spline is made up of several segments, and each of the segments is made up of 2 vertices. So as an example, if you convert a star and a circle primitive into editable splines, so let's just do that now. I'm just going to go up here. I'm going to go down here and let's pick out a star. Let's draw it here. Let me just modify that. And also let's create a circle here. I'll just draw it here. You'll be able to see now what I mean by a spline. If I get this object here and it's already an editable spline. So what I can do is I can click on attach. This is very similar to what we saw with the meshes in DVD2 in the series. I can attach these together and now they form one object. And if I go into sub-object mode, you can see I can select segments. And you can see that these shapes here are actually made up of multiple segments. And obviously each segment is between two vertices. But if I go to spline, and if I click on this object here, you can see it just selects this curve. And if I click on here, you can see it selects all of these segments. And again here, if I click on star, it selects all of these segments. The defining point about a spline in 3ds Max's sense anyway is that it is a group of segments which are all connected together, as you can see here. So just one segment, 4 segments, quite a few segments there. I think it's something like 10 or something. But you can see that they're all connected together, and as a result, they're deemed to be a spline. Now, if I wanted to, I could just, let me see, I could just click on here, click on break, and then let me just move these apart here. And I could do the same here. I could break this. Let's move this apart. And now I could get these two vertices and I could actually weld them together. Just click on weld here. Not quite big enough yet. Just make that larger. That's actually welded those two vertices together there. And now, if I click on segments, it's the same as before. Of course, each one of these is just a segment. But these segments are all connected together now, so it now actually forms a spline. So as you can see, I can just click on it, and we just select it like that. And you'll find the same kind of thing going on with other shapes in 3ds Max. So as an example, if I create some text here, actually very large, isn't it? So let's just reduce the size down a little, make it a little bit more realistic size. And if we right click and say convert to editable spline and go into sub-object mode, you can see it's actually made up of vertices. As you can see here, all these different vertices. And you can see it has curves. You can see here, you can see you've got multiple segments here being used to define these areas. And I can just select any one of those segments if I want to. But if I click on spline and click, you can see that I'm only getting groups of segments that actually all connected together. So you can see the inside of this A letter here is effectively a separate element to the outside here. So I hope that makes sense of what the actual spline sub-object type is. So how do we make a segment into a linear curve? Because it's, it's not particularly obvious how that happens. Well, the easiest thing is to look here at this particular object. If we go into sub-object mode and click on segments, you can see we have segments here. Well, there are two ways. One, we could get the control handles here, and we could kind of edit this. We could point these two lines towards each other, and in this way we could try and get a straight line. But you can see it's still pretty much a curve, and that takes quite a long time to do. So if I just undo those modifications, the easiest way to do it is to actually click on segment, and if you right click on the line, you'll see you've got options here for what the actual segment is. Is it a curve or is it a line? And if it's curved, then it's going to be a cubic spline, and if it's a line, it's going to be a linear spline. So I can just click on there, make it linear, and I can just do that on obviously a large selection at the same time. Just choose that to be linear. I can also click on them again, right click and say curve, and you can see it goes back to the original shape. And that's because the actual control points are still in their original position. You're not actually changing these control points. These stay where they are, and these define the same curve. What you're actually saying is that these segments ignore those control points and just act as linear splines from then on. And that can make it much easier when you want a particular segment to actually have a line shape. If you don't want it to have any curvature whatsoever, the easiest thing is to actually just right click on it and say it's a line. If you want a mixture, if you want it to be slightly curved, then obviously you have to choose curve and work with the actual control points. As you can see, the basic spline primitive is actually pretty easy to work with. it's all pretty straightforward in terms of creation and editing. We just have vertices. Between the two vertices, we have a segment, and that segment can either be a line, it can be linear, or it can be cubic. In other words, it can either be a line or it can be curved. And in 3ds Max, this very basic object is called a spline. And we have a sub-object type, which is called a spline, and that's basically just a bunch of segments which are all connected together. If they're all connected together and you click on one of them, then it selects all of them, and that's actually called a spline. But the actual, all of the segments together and all of the splines together in one node, we refer to that as being an editable spline. And this is one of the basic geometry types in 3ds Max. If you right click here and you look at Convert To, you can see you've got Convert To Editable Spline. So when you're working with some of these shapes here, they're actually procedural while you're working on them. For instance, the text, you can actually type in new text and the shape will change. Once you've finished editing, you can actually right click on it and say Convert to Editable Spline. In terms of limitations, you can actually have as many segments in a 3ds Max spline as you wish. There's no limit whatsoever. And just as with a polygonal object, the vertices in a spline segment can either have an independent position in space, or they can be shared with their position with another vert. When two spline verts share their position, they're referred to as being welded. But if you can imagine, the two control points do not have to actually share the control handles. So in this case, if we look at this particular spline here, and I go back into sub-object mode, you can see that this is effectively being treated as one control point. You can see these segments share this vertex. And it appears at the moment, you can see that this curve, it looks like these two control points are also locked together, that they're effectively sharing a kind of mirrored control point. This is actually just an illusion. This is actually something which is provided to you by 3ds Max to allow you to work with the curve more easily. Simply by holding down the shift key and grabbing one of the control handles, you can see you can actually break that relationship, and now you can see that the two control handles are actually independent of each other. You can define completely different vectors for each of the two segments at that vertex. So just to recap, if two segments share a single vertex, they're thought of as being welded together. You can break them apart at that point and actually turn them into two separate vertices at that point just by using the break button down here. I'll just do that here, and you can see it's actually broken these two apart now. And I'll just undo that until they're back together. And also, you've got the same thing with the actual control vectors here. You can see that originally they were actually locked together, which meant that when you moved one, the other one moved in a similar manner, but mirrored. And this ensured that the curve, as it passed through the vertex, was actually nice and smooth. But if you don't want that, you can just hold on shift and you can break that relationship, and the two become independent again. The easiest way I found of actually making these two handles connect together again is by right-clicking on the vertex and choosing it to be smooth. You can see that it's actually called a Bezier corner at the moment, and that's because these two are actually independent of each other, and therefore, as you can see, it can actually define a corner at that point. But we can also say have it, form a smooth curve, and you don't actually have any control over that curvature. It's a kind of automatic system that you have. And once you've converted it to smooth, I then convert it back to Bezier. And that ensures that the two control vectors are of equal length and they're locked together again. So just to show you that again, I'll actually do that on a number of vertices here just to show you in action. Let me just break this, and we'll break this one too. And now if I wanted to actually put these back together again, having a Bezier to lock the two control points together, we just say smooth, and then we just say Bezier again. So as you can see now, I've got the handles back, and they're both locked together once more. So I can, as I said, you can hold on shift, and then if you right click, you can say Bezier, and as you can see, it locks the two together again. The only thing is that sometimes the two handles aren't of equal length, which is why I usually follow the procedure of saying smooth and then Bezier, and that gives you the two handles of equal strength again.